So we are moving to the next chapter in Halvarian, chapter 5, choice. According to the economics major discipline syllabus, semester 3, the fourth chapter, choice. Because in the syllabus we are not having the first chapter. It starts from 2, that the budget constraint. So this is the fourth chapter according to the syllabus. And this chapter will be covered in this class itself, because here these all are the concepts that we have already studied, and the estimating utility functions and implications of the MRS condition is just for reading. That will be important, but it can be read by yourself. Okay, so we'll move to the chapter 5, choice. So as we said in the previous classes, utility, the more utils from a commodity, we'll prefer that. So there will be a list of preferences and we'll choose one from that. Utility, preference, choice. Okay, so in the first section, that is optimal choice, 5.1 deals with optimal choice. We'll be finding the optimal bundle from a diagram. Okay, so let me erase this. I'll draw it again and show you. First of all, what is optimal choice? It is the choice which gives the consumer maximum level of satisfaction. Okay, the consumer will be at his optimum in that choice. So in this choice, the optimal consumption position is where the indifference curve is tangent to the budget line. Okay, so what is tangency? Tangency is not merely touching the curve. Okay, so here this is the budget line, and this is touching this curve at this side. So this is tangent. The budget line is tangent to the IC. Tangency means, speaking of the mathematical definition, it requires that there be a unique tangent line at each point. So if this is the point at a curve and this has a tangent line like this, and at this point another tangent line like this, and at this point we'll get another unique tangent line. We won't get the same tangent line at any point on a curve. Okay, there will be a unique tangent line at each point of the curve. Got it? So this tangency is not merely touching, but it requires to be unique at each point. So it is considered in the next part. That's why I explained it now itself. So that is what tangency means. So here it states that optimal choice is where the IC, indifference curve, tangent to the budget line. So this is the part where indifference curve is tangent to the budget line. So this is the optimal choice. In the optimal choice, we have the bundles x1 prime and x2 prime. Okay, and such a optimum is called as, like the tangency coming like this, appearing like this, is called as interior optimum. Okay, this is called as interior optimum, not that. So if the IC were in tangent, if such a situation happens, it would cross the budget line, right? If the indifference curve is not tangent, definitely it will cross the budget line. And if it crossed the budget line, there would be some nearby point on the budget line that lies above the IC, like this. Okay, that means what? We could not have started an optimal bundle. Okay, so here this point, okay, this is preferred to what all the bundles beneath the budget line. So there are many bundles here, and we prefer x1 prime, x2 prime to all these bundles, and also there are many bundles here. Higher the IC, we'll get more utils, right? But so here this is the first IC, this is the second IC, and this is the third IC. So according to the concept, we'll get more utils in the third IC, but we can't move there because the budget line only touches here. That is not affordable. The third IC bundles are not affordable for us. So what we are affordable is only up to the second IC. So that is the highest optimal choice that the consumer can have. And we prefer this x1, x2, x1 prime, x2 prime is preferred to the bundles in this IC and also beneath the budget line. And there are exceptions. Okay, exceptions in what case? So even we are studying two exceptions in this chapter where the tangency is not brought up to prove that it is an optimal bundle. The first exception is this. Okay. So here is the budget line tangent to the IC? No. Here the budget line only touches. And we discussed now itself that merely touching doesn't mean that that it is tangent. Tangent means it is required to have a unique tangent line at each point. If we consider a bundle here and here and here, all they will be having the same tangent line, right? So this is not tangent. So here the budget line is not tangent to the IC, but the bundle is here. Optimal bundle is coming here, x1 prime and x2 prime. Okay, and this is called as kinky taste. So here an optimal consumption bundle presented where the IC doesn't have a tangent. Okay, and next is boundary optimum. So in the first diagram we studied what is interior optimum, right? 5.1, figure 5.1 represented interior optimum. Here this 5.3 represents boundary optimum. Okay, what does that mean? So here we see the bundle as in the x1. The bundle is presented in the x1. It has nothing of x2. It has nothing of x2. That means good 2, that is x2, involves zero consumption. That might be because of the reason that price of x2 is larger than x1. So we'll be studying more examples based on this. So this can be because of the reason that P2 greater than P1. Okay, whatever the reason may be, here the consumption of x2 is 0. So the optimal choice, the consumer does not want x2, he only want x1. Then what? Then the optimal choice for him will be x1, because if there is any amount of x2, the consumer won't be satisfied. Optimum choice means what? Most satisfying point, most amount of utils. So the consumer get that only when he only has x1. So it is in this boundary optimum. We call this boundary optimum. Okay. And if the optimal choice involves consuming some of both goods, so that it is an interior optimum. And if there is only one good, that is boundary optimum. Next is this tangency only necessary condition, or is it sufficient to determine the optimal choice? That means from all these examples so in general we noted that tangency condition is necessary for optimality, for finding the most satisfied bundle. But is it only the necessary condition? That means, is it only sufficient condition? No. Okay. Because when we notice this diagram, we can see The indifference curve are like this, right? So itself, the budget line is tangent in 2 points. So these two are optimal bundles. Definitely. These two are optimal bundles. But what about this? This is non-optimal bundle. Okay. So here there are 3 tangencies, but only 2 are optimal bundle. So from this we can realize that tangency condition is necessary, but that is not sufficient. It is not only needed, there will be other conditions also needed. And next is, there is one example or one important case where the tangency is sufficient. That means in that case we only need the tangency to prove the optimal bundle. Nothing else is needed. That is convex preferences. In the last chapter we had studied this. What is convex preference? So this will be like this. Okay. This is a convex preference. This is an example for well-behaved preference, right? So here tangency will be only sufficient, because definitely convex can't be like this, right? A convex cannot be like this or like this. Convex can only be like this. So the tangency condition will be done. Okay. And another thing, convex can't bend back. So here it was convex at a point of time, it was convex, right? Then it bent back like this. If it's a convex preference, it won't bend back. So these 2 conditions make it sufficient for convex preferences to only have this tangency. If the IC are strictly convex, they don't have any flat spot, then there will be only one optimal choice on each budget line. Okay. And next is MRS. So the condition that the MRS must equal the slope of the budget line at an interior optimum is obvious graphically, but what does it mean economically? Okay, so we know the interpretations of the MRS in the rate of exchange, E, like MRS equal to minus P1 by P2 price ratio will make the consumer stay at that point. If MRS is not equal to the price ratio, consumer will won't be in his or her optimum. Okay. So if you give up one unit of good one, you can buy P1 by P2 units of good 2. If the consumer is at a consumption bundle where he or she is willing to stay put, it must be one where the MRS is equal to the rate of exchange. Okay. And another way to think about this is to imagine what would happen if the MRS were different from the price ratio. That means if such a situation happens, delta x2 by delta x1, that is the MRS, equal to minus 1 by 2, and the price ratio is 1 by 1. This means that the consumer is just willing to give up 2 units of good 1 in order to get 1 unit of good 2. But the market is willing to exchange them on a 1-to-1 basis. Thus the consumer would certainly be willing to give up some of good 1 in order to purchase a little more good 2 whenever the MRS is different from the price ratio and the consumer cannot be at his or her optimal choice. So next is consumer demand. We know what is a demand function. It is the function that relates the optimal choice, the quantities demanded, to the different value of prices and income. Okay. Optimal choice of goods 1 and 2 at some set of prices and income is called the consumer's demanded bundle, because the optimal choices were the consumer demand. And how can we write the demand functions depending both the prices? This is the way we write them. So x1, the price is confronted by x1, p1, p2, m, like m is income, So this is the thing on demand function. Next is examples. Okay, so we know perfect substitutes. You guys will be remembering the example of blue pencil and red pencil, right? So in perfect substitutes, for the optimal choice, there are three conditions. Three possible cases. So this is very, very important. Okay. So as I said, the consumer doesn't care the color of the pencil. He just wants those number of pencils. So if X2 is in a higher price, consumer will only spend money to buy X1 because he doesn't care the color. He just want a number. So X2 is higher price, then why should he buy them? He'll just go with the X1, which is cheaper. Okay, so that is when P2 greater than P1, all his money will be spent on to buy X1. That is his money, income, M by P1. Okay, all his money spent for X1, that is M by P1. Money divided by P1. Okay, then if P1 is equal to P2, I'll show them in the graph. So if P1 is, if P2 is greater than P1, as we said in the first example, it will be here, right? M by P1. And if P1 is equal to P2, it will be in any part of this budget line. Any number between 0 and M by P1. 0 and M by P1. Okay. And what happens when, so here it is P1 P2. Then what is next? When is it 0? X1 is 0 when? When the price of X1 is so high. So consumer won't buy that. If he needs 20 pencils, he can either buy 10 red and 10 blue. Okay. And if the red pencils are highly priced, very costly, he will not buy the red pencil. He will buy 20 blue pencils. So all his money would be here. That is red pencil 0, blue pencil. That is the cheaper pencil 20. Okay. That is at this point. So at this point X1 will be 0. And at this point X2 will be 0. That's it. That means for perfect substitutes, optimal choice will usually be on boundary. Next is perfect complements. Okay, so this is perfect complement. We know how this indifference curve be in the L shape and all. I'm not explaining it again and again. So in perfect complement, the thing we know is that X1 is equal to X2. So here we are citing the example of 1:1. So left shoe and right shoe. In other cases, like 1 car, 5 liter petrol, 2 car, 10 liter of petrol. There are examples like that, but here we are citing the example of, for the convenience, like for you guys to get it very easily, we are citing the example of left shoe and right shoe. So X1, left shoe, number of left shoe must be equal to number of right shoe. So X1 is equal to X2, so we can simply denote them as X. And what is this X? M by P1 plus P2. M by P1 plus P2. Okay. If the goods are perfect complements, the quantities demanded will always lie on the diagonal, since the optimal choice occurs when X1 is equal to X2. So this will be on the diagonal only. Okay. Optimal choice will be on the diagonal only. Got it, I guess. And next is discrete goods. Yeah. So we know discrete goods will be like in 1 unit, like 0 unit, 1 unit, 2 unit. Okay. And if the price of good one is very high, then the consumer will choose 0 units of consumption. And if the price of good one decreases, then he will find it optimal to consume 1 unit of good. And when the price decreases further, consumer will choose to consume more units of good one. Okay. So good one is determined as car or any other particular good. Anyway, then good 2 will be the money that the consumer is ready to spend on other goods other than good one. Okay. So how will the consumption bundles come? How will the consumption bundles come? I'll denote it. So it will be like this only. That is 1 unit, then money income minus P1. Then when the price again decreases, when the price of good one again decreases, you will consume it 2 units. Then it will be M minus 2P1. Okay, 2 is the quantity, P1 is the price. So the money spent for 2 units will be 2P1, M minus 2P1. It goes like that. Okay. So this is what discrete goods are about, and next is neutrals and bads. We know what they are. Right? So in the case of neutral goods, the consumer spends all her money on the good she likes and doesn't purchase any of the neutral good. Okay, that means here the consumer's main goal is to be in optimum, to get maximum satisfaction. If the consumer is neutral to one good and happy with the other good, like getting neutrals in the other good, why should she spend on the neutral good? She'll spend her all money in this the other good, where she get neutrals. Same thing happens if one commodity is bad. The same thing with neutral happens with bad also, because consumer won't spend money there. She spend all her money on the good only. So it is also having this boundary thing, because x2 is 0 and x1 is m by p1. All the money is spent for x1 only, because x2 is either neutral or bad. X2 is either neutral or bad. Next is concave preferences. So when does the preferences come like this? When does the preference come like this? So here X is not an optimal choice. Why? Optimal choice for these preferences is always going to be a boundary choice, like bundle set, right? So non-convex means what? Like if you have money to purchase ice cream and olives, so that is the example given in the textbook, we'll go with that in the readings, okay? So you don't like to consume them together. You have ice cream and olives and you don't want them like 5 ice creams and 5 olives. No, you don't want them in that case. You just want 8 ice creams and 2 olives, or 2 ice creams and 8 olives, but not equal amount. So in that sense, in that case, it will be in the boundary, likely to be in the boundary. It won't be anyway in the center. It won't be like tangent like this. It won't bring any tangency. Okay. And anyway, Z is on the higher IC. And next is Cobb-Douglas. Cobb-Douglas is something all are puzzled of. So I'll explain it with the help of appendix. It gives more explanation, more vividly. Let me take it. Aren't we provided with the appendixes here? So we know how the utility function of Cobb-Douglas is derived, right? So first we need to take the monotonic transformation. Seeing the logarithm, don't need to be worried. It is just for this step. If you don't know logarithm and you're having exam tomorrow, just by heart this, okay? Take the log of this, both the goods like this. Just write like this, okay? And so what we need here is this. Next, we'll start with the budget constraint equation. Okay, so we know this is the budget constraint equation. We can write it in this way also. No, just rearranging. Okay. Like we know x2 by x1 is equal to p1 by p2. So C and D will be given as coefficients according to the Cobb-Douglas. Then just rearrange it. We know already this is what the equation is, and we substitute the x2 of the cx2 with this equations, like rearranging the equation by getting x2 as a result. Okay, so this is how we get, and we'll just cross multiply it. Okay, cross multiply both sides, we'll get this answer. Rearranging this and we'll get this. That's it. So this is how Cobb-Douglas utility function is derived. We'll go to the problem again. Okay. So you can study that. And next is Cobb-Douglas consumer always spends a fixed fraction of his income on each good. Size of the fraction is determined by the exponent in the Cobb-Douglas function. So the exponent sum is 1, like this. Okay. So from this we get that A is the fraction that to be spent, fraction of income that to be spent on good 1. And 5.4, then 5.5 also, not 5.5, 5.4, you will read them by yourself. That is estimating utility function and implications of 5.5, implications of MRS condition. Now we will go with the choosing tax. So this is a very easy topic. It simply means that what will generate more income, more revenue for the government, income tax or quantity tax. We studied what income tax, quantity tax and value tax in the budget constraint chapter. So first we will start with the budget constraint, the equation. This is the equation, right? And first we are imposing the quantity tax. Quantity tax will be like P1 plus T, right? Quantity tax is imposed on quantities of, units of good. So it will be like P1 plus T. Got it? Then we know when the price of one good is increased, the quantity demanded of that good and the other good, x1 and x2, will change. So we'll get x1 prime and x2 prime here. Then, so from this we'll get the revenue raised by the taxes r prime, tx1 prime, whatever. So we'll just take this the other side. We'll reduce it. So this is how we write a budget constraint. We'll reduce it in the other part. Substituting, we write it as minus tx1. Next is, so here the budget line with income tax must pass through the point. I'll take the diagram. So in this diagram, so it is easy to see that it has the same slope as the budget line. That is when this was our original. I'll take the pencil. So this was our original choice. this gray one. Okay, when the price increased with T, when the quantity tax was imposed, this became this. Then what happened? So this law became minus P1 plus T by P2. And here we have the bundle at this part. Now x1 prime and x2 prime lies on the income tax budget line. Right. In the income tax we are having, so this is the income tax. This is the income tax, and x1 prime and x2 prime lies here only. So the MRS will be minus P1 plus T by P2, but the income tax allows us to trade at a rate of exchange of minus P1 by P2, right? So if you are getting confused with the slope, just imagine that this is on higher IC. So this is the point. I'll redraw. So this is the point where the quantity tax imposed bundle get, and this is where the point where the IC of income tax brings, the optimal choice income tax brings. So this is on higher IC. So this quantity tax only makes the consumer more worse. Income tax is superior. Okay, that's it with the income tax. And next is, there are two limitations. First one is that income tax is not, so it is better for the government to apply income tax because the consumer will be more better off in income tax other than the comparing to the quantity tax. Two limitations here is that it's not uniform, like the income tax is not uniform, and even if the income tax is uniform, think if a consumer doesn't consume any of the good one, the person would certainly prefer the quantity tax to a uniform income tax because he doesn't want good one. If the quantity is taxed, if the price of good one is increased, he doesn't care because he doesn't want good one, he is just dependent on good two. So for such a person who doesn't depend on good one, quantity tax is better. Otherwise uniform income tax will be better, but then also there are like different people, different preferences. That is just to be in the position of limitation itself. Next is, so we know that income tax is a lump sum tax, right? So it changes the amount of money a consumer has to spend, but doesn't affect any choices he has to make. That means after tax income will fall even by more, like after tax income will fall because of this lump sum tax, that is income tax. See, if your after tax money is decreasing, will you be encouraged to work or earn income? If your money earned is decreasing, your interest to work and earn money will also decrease. That is, the income tax discourages earning income. Okay. Then there is another supply response to the tax. So in the chapter of endowment, we will study that deeply. So that's it with this chapter. In the next class, we can start with the next chapter, that is demand. So bye.